we did in Small World. Do you guys remember doing something similar to this in Small World? Okay? And that's what all the calculus is built on, or at least the first half, the derivative half. So they come in, let me turn both up. But the only thing you're going to do, listen up you guys should help. The only thing you're going to do for the first half is find the change in y over change in x. Okay? What? Okay, there we go. Now, we're going to start out on an interval. So for any function or anything, we're going to find the average rate of change. We're going to find that by taking the y2 minus y1 over x2 minus x1 on some interval. So if it's on the interval 1, 3, you got the x value 1, y value 1, x value 3, y value 9. And find the slope between those 2 points. That's what we're going to call the average rate of change. If we connect those 2 points, that average rate of change is the slope of the line connecting them. And the line connecting those 2 points, we're going to call the secant line. Okay? So the average rate of change, there's 2 big different things we're going to be talking about. Average rate of change and instantaneous rate of change. The average rate of change is on some interval, the change in y over change in x. That change in y over change in x is going to be the value of the slope of the secant line that connects the 2 points. Does that make sense, you guys? That's average rate of change. Here's what the guys did that bothered everyone back in the day. When you have this secant line, the closer you move the 2 points closer together, the better the approximation is for that instantaneous rate of change in a point. But you need 2 points. You need a change in y over change in x to get that slope or rate of change. Does that make sense, Estella? So you need the 2 points algebraically. Otherwise, you have this, your change in y is 0 and your change in x is 0. So it's this 0 over 0, the indeterminate form again. Does that make sense? But geometrically, we can do this. We can take this point from here, and we can move the other point closer. You see what's happening here, Jessica? And what you can actually do is put one point on top of the other point. And then that line in between them is going to be the tangent line. The slope of that line is going to be the instantaneous rate of change, or the derivative at that point. That's what the big fight was back in the day. Geometrically, Joanna, you can see what happens. You know what I'm saying? This line that connects the two, you can still draw a line that's sort of going to approximate the rate of change at a point. Do you guys see that geometrically? You can take this point and physically move it down to here and still connect the points. Connect the point, you know, it's going to be a line, a line, a line, a line. And then it's just going to be one point on top of another, and you're still going to get this tangent line that's doing something like that. Does that make sense? That's what we're doing. We're taking this average rate of change on any interval that you guys have been doing, the slope between 2 points. We're going to find the slope between 2 points. Call that the secant line. The average rate of change is going to be that slope value. We're going to move the points closer and closer. When we put the points on top of each other, we're going to have a change in y over change in x of 0. But geometrically, I can still see the tangent line. And with this line, you can still get a slope. And that's what we're going to be working on this first semester. Okay? It's just figuring out what that number is and how to get that number. Okay? So again, average rate of change is the secant line. Instantaneous rate of change is that tangent line. It's at 1 point. 1 point tells you what that instantaneous rate of change, or what the slope is of that curve at that point. Any questions on any of that? Okay? Well, let's look at an example. So how do we do this? Well, we have this point. Here's x squared. We have a little example. Does anyone know what the Latin is? E.g. for example? I always wrote that since I was your age, but I don't know what it stands for. Any Latin people? Or example given? No, it's not that easy.
Exemplification. rock juice or something.
Is it juice speak Latin?
No.
Anyways, that's what EG is. You're going to see a lot of EGs or EX. They mean the same thing, it's just for example. Okay? So, here is a point on the x squared function. I got y equals x squared. And I want to know what that instantaneous rate of change is right at that point. Okay? So on the interval was above. You can take two endpoints and you can find that rate of change. Alright? And again, what they were dealing with back in the day is, if you have that total distance traveled divided by the total time, when you take distance divided by time, you get a velocity. You get an average rate of change, or an average velocity, on that interval. If you move those points closer and closer together, that little distance and that little time, that's going to be the instantaneous velocity. And that's what they were working on. That was their application back in the day. How fast is something going at a certain time? Because average velocity over time, it's like, it's okay, but wouldn't it be neat to know how fast we're going right at this time, right now? And this is how they were working on it. Allie, how are we feeling with that? So here's what they did. You got this function y equals x squared. And it has a point on it. By plugging in a x value of 2, I have a y value of 4. Okay? Now what I want to do is, here's that point right here. Here's 2, 4. This is where all the magic's going to happen. I want to see if I can solve for the instantaneous rate of change at that point right there. Well, if I draw it like this, would be what the tangent line would look like. So that instantaneous rate of change would be the slope of that line at that point. So if I take 2 points that are like, just next to each other, just like that, that would give me a pretty good approximation. The closer I move those 2 points, the better the approximation at that point. Do you agree with that? Okay, so here's what I'm going to do. I have the point 2, 2, 4, and I'm just going to go over just a tiny smidgen. I'm going to call that little smidgen h. I'm just going to go over just a little bit h, whatever that is. It's just a really small number. So my new point, this little dot I drew up here, is going to be 2 plus h. Does that make sense? If you just go over a tiny little bit h, then this is going to be 2 plus whatever that h is, and that's going to be the x value. Okay? What's the y value going to be? Well, if you plug this into this function, you're going to get 2 plus h squared. And that's going to be the y value. This is 4, and then this is going to be, I squared 2. This was f of 2, or 2 squared was 4. What's this 2 plus h value? Well, it's going to be 2 plus h squared, whatever that is. Okay, Rafi? So I have 2 points. I have the point 2, 4, and then I have the point 2 plus h, wherever that is, for some small h. And then the y value is going to be 2 plus h squared. I have 2 points, and I want to find the slope between those 2 points. I want to find the rate of change between them. So I do the same thing I've always done. y2 minus y1 over x2 minus x1. Same as we've always done. Change in y over change in x is equal to, I'm just going to take this point first. Why? Because I feel like it, Roxana. You could have gone this one first minus that. You can if you want to do that. But I'm going to go, I want to know what is the rate of change between these 2 points. So this point, this y point, minus this point, over y2 minus y1 over x2 minus x1. That would give you the rate of change. Would you agree with that, David? What I want to do, though, is I want that h to get ridiculously small. Well, could I plug it in for 0? Well, if I just simplify this denominator, I get 2 plus h squared minus 4 over h, because 2 minus 2 is 0. So can I have an h value of 0? What do I get? You get actually 0 over 0. You get the indeterminate form. Do you see that? Because if you plug in 0 into the numerator, you get 2 plus 0, which is 2 squared, is 4. Minus 4 is 0 over 0. Indeterminate form again. So we have to do some work on it.